Welcome back, Chemistry 30. Let's take a look at the example I left you with. So again, this is an acid solution, so we have to take that in mind. We're going to add H2Os and H pluses. So just to rewrite this here, just to make it bigger so we have more room to work with. So oxygen is -2. 2 times 4 is -8. And of course we're going to end up with a charge of -1 here, which means this must be +7. Each chlorine is +7. -1, -1. So it's a bromine here that has a charge of negative. So it's not going to be 0. It's going to be equal to that charge here. So remember from before, it's just an atom will have a oxidation number of 0, but if it's an ion, the oxidation number is equal to the charge. Just like over here, 2 bromine atoms together, so that is 0 and 0. But if it's in an ion form, it has to have that same charge. So if we look at what's happening here, chlorine is going from +7 to -1, so that's a gain of a lot of electrons. Gain electrons, reduction. So go from 7 to -1. 6, 5, 4, 3, 2, 1, 0, -1. So that's a change of -8 if you look at a number line. Then over here, bromine, going from -1 to 0, that is getting more positive, which means we lost electrons. Oxidized, -1 to 0, +1. Okay? So you can always draw a number line to see what the total change is here that's happening. So to get this identical, 8 and 1, the lowest common multiple of 8 and 1 is 8, of course. So if I have 8 of these, I'll have these matching now, because remember, whatever's being lost must be gained somewhere else. So ClO4 negative plus 8 bromines. Now, to get 8 over here, this means that I need to have 8 bromines. So yeah, if I have 1 bromine to make 8, I put an 8 in front. Now what can I do over here to make 8 bromines? Each of these has 2 bromines, so of course that requires a 4 there. So 8 bromines, 8 bromines. All right, now acid solution. In the previous example, the first thing I do is I add water to the side that is short of oxygens. Let's see where we're short. Here we have 4 oxygens. Here we have no oxygens. So I'm going to have to add to the left, or sorry, to the right. So to the right, let's see, I need 4 O's. So to get 4 O's, I need to add 4 water. And then, the chances are to the opposite side, I'm going to have, now it just so works here that H2O is on the right-hand side. That isn't always the case. Add H pluses to where we're short on H's. So let's see what I have here. I have a total of 4 times 2, which is 8 H's. Here I have no H's. So I'm going to have to add a total of 8 H's to that side. And if we took a look at this, it should be balanced. 8 H's, 8 H's. 4 O's, 4 O's, 8 Br's, 8 Br's, 1 Cl, 1 Cl. So the remaining part of the assignment deals with questions like this in acid solutions in which you add H2O to make up for short oxygens and then H's to the opposite side to make up for the H's that you've added. Now on the last page here, I didn't put any of these on the assignment, but just so you know, and we can have a basic solution in which we have to add OHs and H2Os to each side. Now these are more tricky because when you add the other one you add water and H's. There's no oxygen on the H's, but here it's kind of tricky because we have both. Both of these have H's and O's, so it can be a little tricky at times. So what I did for this question is I gave a hint. Hydroxide ions will appear on the right, water molecules on the left. Okay, so let's take a look at here. Well, again, I'll rewrite this just so that it is bigger so we can see what's going on when I'm determining what's oxidized and what's reduced. So ion of -1 Oxygen's -2. 2 times 4 is -8. We have to result in a charge of this. So that means +7. Since we have one of these, +7. A molecule is this 0. No charge here, so this must add up to be 0. All right. So the iodine, we see something is happening there. We're going from -1 to 0. So that's going to the right on the number line. That is oxidized. And the net change that's happening there is a -1. Or sorry, +1. Going from -1 to 0. And oxygen's not changing, but manganese is changing. It's going from +7 to +4. We're going down the number line to the negative. So that's being reduced. The change there, so we're starting at 7, 6, 5, 4. So that's a change of 3. All right. So to make these equal, the lowest common multiple, so you see you'll have simple numbers like this. 1 and 3, the lowest common multiple is 3. So 3 times +1 gives me +3. So I'm going to have 3 iodines. Okay? 3 iodines. So let's just rewrite this. Rewrite it out here to see what's going on. 3 iodines we need to have. So 3 iodines. Now over here, this is tricky. We have 2 iodines. How do I make 3 when I have 2? What can I multiply 2 by to get 3? Well, if I have 1 here, 1 gives me 2. If I have 2 here, 2 gives me 4. So what's smack dab in the middle? 1.5. If I have 2 times 1.5 gives me 3. But of course, I can't have fractions of molecules. So if you recall back in Science 10 or Physical Science 20, to get rid of having fractions or decimals, I need to double everything. Just like you did back then when you were balancing something. If you end up with fractions or decimals, you double everything. And really, you're not changing anything by doing that. So 3 doubled is 6. 1 doubled is 2. 1.5 doubled, of course, is 3. And then 1 doubled is 2. Okay, so we haven't changed anything. We just simply doubled everything. 6 I's, 6 I's. 2 MN's, 2 MN's. 2 times 4 is 8. 2 times 2 is 4. Okay, so now we have to, the hint here, if it's in basic solution, we have hydroxides and waters to add. And it would take quite a bit of time to figure out which side each goes on. So I kind of gave a hint. We're going to have OHs on this side and water on this side. We just have to figure out how much. Okay, so I'm going to grab a pencil here just to figure this out first of all. Now, there's an issue here. There's kind of a hint here. H's come in sets of 2 on the left-hand side. So I need my H's to come in sets of 2 on this side. So if I had put a 2 here, that gives me my 2 H's and 2 H's, but look what I have for O's here. 2 times 4 is 8, plus 1 is 9. And here I have 4, 5, 6. So that's not going to work. That's not going to work. So again, so if I tried 2 there, let's try the next even number, because I know H's come in even numbers on the left-hand side. Let's try 4. That's going to give me 4 H's. To get 4 H's over here, I'm going to have a 2. And if you notice the last time there, I had an odd number here. Now it's going to be an even number. 2 O's plus 2 times 4 is 8. 2 plus 8 is 10 O's on this side. And over here, I have, let's see, I have 4 here and 4 here. So I'm still short. I'm getting closer, though. Getting closer. So let's try 6. So that's going to give me 6 H's. To get 6 H's, I need a 3 there, so that's 6 H's. And in terms of O's here, what do I have? Oh, 6 H's, so 6 H's. So 6 H's, so that's going to give me 3 plus 8 is 11 O's. And yeah, I'm close here. I have 10 O's. So let's just do that one more time. Go up to 8 maybe this time. 8 H's, 8 H's. 4 O's plus 8 O's is 12 O's. And then here I have 4 O's plus 8 O's is 12 O's. There we go. We got it. So you can see in basic solutions, it's a little more tricky. So we've done that there. Let's see. Do we need to do anything else here? So 8 H's, 8 H's, 4 O's, 4 plus 8 is 12, 4 plus 8 is 12, 6 I's, 6 I's, 2 MN's, 2 MN's. There we go. Now I didn't throw any basic ones on the assignment. I just have acid ones, so you should be able to, it's a little bit easier. You can figure out where you're short of O's, add H2O's, and that H is on the opposite side. All right, so that's balancing by the oxidation number method. You should be able to do the assignment now. We'll see you again.